get that all set. All right. I think everything is ready to go. And this is one more thing. And okay. All right, so now I am ready for you guys. So any question that you guys might have can be from any of the homework assignments, or it could be just something kind of general content related. We'll take a few minutes at the end to talk specifics about like the test format or whatnot. So if you can hold off on that. Start with Amy. I thought it was Amy, but then I had to double check. I started second guessing myself. Sure. I don't have answer keys written out for these, which is probably not the answer you're hoping for. But if you want to talk about something specifically, I'm happy to talk about specific things. And certainly I've blocked off really all of today to just kind of have you guys pepper me with questions, and we can certainly cover a lot of answers in that way. So it's something. Thomas, do you like Tommy?
Yeah.
Okay, Tommy. Well, I'll start calling you like Butthead or something if you say whatever. You probably don't want. Be careful on that.
Right.
I'm gonna go with Tommy.
All right, sounds good.
Okay.
So for number one on the review, can you go over that one?
Sure. So this is, I think, the trickiest of these first four in some way. So the first thing we should do is try to determine if the relation is a function. Okay? So what I'm going to do is I'm going to concentrate on this rule and see if I can come up with 1x that gives me two different values for y. Okay with that? So probably the easiest thing to do would be to start by rearranging this so I get the y by itself. Oh, thank you. I appreciate you not waiting for me to get like too deep into this before making mention that like, hey dummy, we can't see anything that you're talking about, which is totally fair when you can't see anything I'm talking about. Okay, so I'm going to focus on the rule part of this, and I'm just going to try to rearrange things so I can get the y by itself. So when I do that, I get this. Is everybody okay with that idea? Okay. Now, ideally, I can just pick any old value for x, and if I get two different y's, that's my evidence that it's not a function, right? So maybe I just say, well, let's pick x to be like -1. Right? That would tell me y is plus or minus the square root of 2. So I have these 2 points, right? Which would indicate that I don't have a function. Little problem with what we've done here, though. We have this part also. It tells me that x and y have to be integers. If I look at what I've done here, our y isn't an integer. So we have to be a little bit more careful than that in our choice of x. So let's say that we think about, I want our choice of x to give me a perfect square underneath the radical, because I know if I take the square root of a perfect square, that's going to give me an integer back. So what's a good value for x that I could use? About 1, because 1 minus 1 is 0, and 0 is a perfect square. Another good one might be negative 3. 1 minus a negative 3 is 4. That would be fine. 0 would be a good one. 1 minus 0 is 1. That's a perfect square. So that's kind of what you'd want to go about doing. Oh, but this isn't a good one. Why not? Because plus or minus 0 is just 0. So I got just 1. So that's not a good example. Let's do 0 then for x. And that's going to give me what we want. Okay with that? So again, I didn't go the most direct route through here. I kind of played with it so you guys could kind of see me think through how to do something like this, because there's not just like, this is the procedure, we do the procedure every time, just like a robot. Definitely kind of helps to kind of think about it a little bit creatively and like, what are we really looking to do? How can I get that? What do I need to be wary about when I'm trying to generate my counterexample or whatever? So that's like part A. So lots of examples of things that you could come up with, pairs of like a value for x and y that demonstrates that we're not a function. So that's our part B also. This is no, it's not a function. As soon as I saw the plus or minus pop up when I rearrange things, that's a good indicator. And my reason here, I've shown that this x gives me 2 different y's. So that's like my part B. And part C asks to write down the domain and range. Well, this is actually the easiest part for this. Well, kind of the easiest part anyways. So I know that because x and y have to be integers, our domain and range also have to be at least a subset of the integers, whether it's all of the integers or just some of them. I know it can't be, I can't use like an interval to describe the domain and range here. So if we think about it, can I pick any old value for x and plug it in here? No, because like if I picked x to be 2, I'd get the square root of negative 1, and we can't take the square root of negative 1, right? What's the biggest value of x that I can plug in here and still be able to take the square root of it? One, right? Anything bigger than 1, I'm going to get a negative value. Everybody agree with that? And then anything less than 1 is going to be okay to plug in. Right? Because then I'll have minus and negative, which is like adding, and I'll end up with a positive value under the square root. Is that okay for everybody? So what my domain is going to be, it's going to be the set of x's such that x is greater than or equal to 1, and x is an integer. Yes. I have 1x giving me 2 different y's. Yep. Exactly. We still got to do the range. Is this related to the... Okay, yeah, go.
So I'm confused as to why if you plug in a positive number, it automatically.
Well, like, because it's 1 minus x is the part that's underneath the square root. So if anything bigger than 1 I plug in, I get a negative, and then we're in trouble, right? Amy? Okay. Uh-huh. So this was just when I plug -1 in here, 1 minus a -1 is 1 plus 1, which is 2. So I'm left with the square root of 2. Is that okay? Okay, we still have to do the range, though. Okay.
I think I'm just confusing myself, but for the last part, how can x be less than or greater than 1 and then also be?
So you're thinking about it in the wrong order.
Yeah.
You're thinking about it as x has to be an integer that's greater than or equal to 1. Oh, we meant less than or equal to 1. Goodness gracious, thank you. Is that what you're complaining about? Because it definitely should be less than or equal to 1. No, okay. So let's think about the integers that are less than or equal to 1. You have 1, you have 0, you have -1, -2, -3, and so on, right?
Yeah.
So that's what we want, are the numbers like that. We want the integers, and we know we need integers because of this part, and that are also less than 1, because we established that when we have that square root there. Does that feel better?
Yeah.
Okay. So I think you're thinking about it in the wrong order.
Yeah.
Right? You're thinking about, everything less than 1 that's an integer. I would think about all the integers that are less than 1, and that makes it a little bit easier. Mackenzie. Yes.
I'm just confused on how this is.
Sure. Yep.
How does it just
Okay. Okay. So where you go with how I rearrange to get to here, the part that I just circled in green. Okay. So when I look at this, when I'm thinking about a domain, I'm thinking about what part of this function can give me something that's undefined. Okay? If there's nothing that can give me undefined, the domain is just going to be like whatever, like all real numbers, or in this case, all the integers. But here something can get undefined because I have this square root going on, right? When is a square root undefined? When you're taking the square root of a negative. Okay with that? So I know whatever is underneath the square root, in this case it's 1 minus x, that has to be non-negative, greater than or equal to 0. Okay with that? So if I tried to solve for x, I'd get that x has to be less than or equal to 1. So you can think about it that way as well. This is a little bit more formal way of kind of coming up with that inequality that we just kind of did. I did intuitively, but if you're looking for like a procedure, that's a little bit more procedural, if that helps, Mackenzie. Did that help? Okay. If it didn't, you can say it didn't, and we can try it again doing something different, or I can try to re-explain it. Okay, you feel good? Okay. So again, perfectly reasonable to ask, like, somebody else has already asked about this, but I still don't get it. Can you, like, do it again? That's okay, right? And I might do it completely different when somebody asks me, can we do it again? Because, if they didn't understand it the first way, me doing it again over again the same way maybe isn't all that productive. Edmund.
I just want to make sure, so the goal is to find out, adding since the author found this.
Yeah, so when I'm thinking about a domain, I'm thinking about, okay, is there something that can make this undefined? And then I want everything that doesn't make it undefined then, which is what I did here. So I want, okay, if it's negative, that gets me in trouble. So I want everything but the negatives. Okay, should we do the range? Okay, the range is actually easy, or easier, because it's based on the domain, basically, right? So can the domain, is there a value for x that gives me a y value of 0? Yeah, we found it already, right? When we were searching for our counterexample. Right? Is there a value for x that'll give me a y value of positive 1? Yeah, we found it right there. Is there a value for x that can give me a y value of -1? Yeah, we found it. It's right there also. Will I be able to find an x value that gets me positive, or an x value that gives me a y of +2 and -2? Yeah, right? What would it be in this case? If x equals -3, y would end up being ±2. Right? You guys are looking at me like I'm weird. Okay, let's try thinking about it a different way then. That's okay. So let's go back to this piece. Okay. Actually, check that. Let's go back to this piece. If I pick a value for y, will I be able to find a value of x? Will I be able to solve for any x after that? Yes, right? Because to solve for x, all I have to do is subtract whatever this is to the other side. So that tells me the range is all the integers, right? I'll always be able to find an x that gives me a specific y value, right? Like name a value for y. 10. Okay. So to get y equals 10, x just has to be -99. No matter what y value you pick, as long as it's an integer, I'll be able to find an x that'll give me that y, right? We can kind of see that. So I can tell then that the range is going to be everything that I can use, which in this case is just the integers. This was the hardest one of these four, by the way, I think.
Like, you know, the original, like, not formula, but the original equation, like, had, like, the x, the whole thing, and equals to
This part right here?
yeah. Is that where we got, like, how we know it's gotta be integers?
Yes.
Okay.
Yes. So that's part of the rule, right? Like, you have to satisfy this equation, and both the x and y's have to be integers. So good, yep, good question. Again, like making sure you understand the notation is important to being able to answer the question, right? If you don't understand what things mean, really difficult to answer the question, particularly in a situation like this where the definition really matters what's going on here, because that's all we're using to do our figuring this out is the definitions. Zach, aka Doritos.
How would we like phrase when it says justify your answer? I put that there was repeating x values. Like, how would we rephrase that justification?
So if that's a perfectly reasonable justification, I would include an example of it, such a repeating x value like we did here, where I said if we did x equals 0, y would be ±1. And I would say that's perfectly reasonable. So you don't even have to do it as a sentence. You can just say if x equals 0, y is ±1. And that would be fine.
Okay.
Does that feel okay?
Yeah.
Okay. Sergio.
So, for the range, like, why wouldn't you put the bracket? Like, that's the way to right?
Oh, I mean, you could if you wanted to.
Okay.
I wouldn't be. The only reason I don't feel like you need to there is because the integers is already a set. You're just saying y is, the range is just the stuff in the integers, which is already a set.
Yeah.
But if you wanted to, it's certainly not wrong to do that. Alyssa?
Yeah.
Mia?
Yeah,
Is that?
I know the word in there.
Oh,
Can you just like give me the answers for number 2, just so I don't want to do it?
I mean, 2 on the review.
Yeah.
Oh,
Yeah.
that we can see on this page.
Mhm.
Okay, so there's not a function, right? fail a vertical line test. And the domain is going to be like, you're going to have to do like a little bit of estimation here because the points on the x-axis aren't labeled. So maybe like, answers could vary, but like maybe negative 1.8 to, I don't know, 0.8. And then say like 1 to positive infinity.
Okay, and that would be like, because I did the same numbers, I just did it like, like the greater or less.
Oh, I mean, you could certainly write this as inequality, sure. Like 1.8 is less than or equal to x, which is less than or equal to 0.8, or 1 is greater than or equal to, x is greater than or equal to 1. Like that I'd mark that as correct. Unless I told you specifically that I wanted intervals. That's a perfectly reasonable way to describe the domain there. So you could certainly write it that way. That's okay.
Would that be in, what would you write around that?
I would just write that. Alternatively, you could also say like the set of x's such that, and you could write it that way as well. And that's correct. And that's okay. These are good questions. Amy? Sure. So the range, we just care about the y coordinates, right? So I'm going to look for the highest and lowest point on the graph. So the lowest point is down here at, say, if we describe that point, it's at like positive infinity because we're going to the right, and negative infinity because it's kind of going down. And the highest point would be up here, which is like positive infinity, comma, positive infinity. Right? And those two are connected. So my lowest point starts at negative infinity and ends at positive infinity. And they're connected everywhere in between. So all the y values in between get covered. This part doesn't matter at all for the range. And the reason it doesn't is because any y value here is also a y value on the wedge part. So I don't even have to worry about that circle piece when it comes to the range. It definitely matters for the domain, though, because like there's a whole bunch of x's, oh, not that over there, that aren't covered. Because we have arrows going only to the right. We don't have another arrow going to the left. Does that feel okay? Yeah, good. Alyssa.
How did you not put the negative infinity first?
So when we write an interval, we always go smallest to biggest.
Okay.
So that's always in that order. Sergio.
I'm sorry, but how do you know when you do a bracket, set brackets or not?
Okay. So a bracket means that there is a point on our graph that uses that specific coordinate. So if I call this point 1.8 comma 0, I have a x value on my graph that used that coordinate. Is that okay?
Like, can you just, yeah, like the squiggly one.
Oh, the squiggly ones. Okay. When do I use the squiggly ones?
Yeah.
I mean, kind of whenever you'd want to. So like,
So you theoretically could use it there or no?
for this,
No, for the second domain.
for the range.
No, like, you know,
So these two answers are equivalent. Either is fine. Without preference, I would give you full credit for either one. I would even give you full credit if you just did that. Still full credit, correct answer. Is that what you're asking?
kind of.
Kind of.
I think that's fine. I don't even know what I'm asking.
Okay. If it comes up and you're like, this is what it was, interrupt again. Okay. I'm happy to go back and backtrack to it. Okay. Mackenzie?
So for like 5, 6, 7, I don't really understand how to write end behavior.
Okay. Well, that's because all of these are bad questions to ask you to write end behavior on, which is my fault, not anything to do with yours. So the end behavior should describe what the arrows at the end of the graph are doing, right? So if I look at 6, do I have arrows at the end of the graph? No, the graph ends. So is there any end behavior? No. So there's nothing to do for 6. Is that okay? If I look at 7, are there arrows at the end? No, the graph just stops. Is there end behavior to do it? No. So they can't do it there. Is that okay? Let's talk about 5's end behavior, because I skipped it for a reason. So 5 is a bad question, or is a bad situation for me to give you all around, because I say, like, assume there's arrows at the end of the graph, but it's unclear what the arrows at the end of the graph should really be doing, right? Am I just assuming it's doing this? Am I assuming it's doing this? Am I assuming it's doing this? And just keep on going? It's not, from where you're sitting, there's no way that I would expect you to be able to guess which one of those things should be happening, which makes doing the end behavior and really the rest of this question kind of impossible. So it is a poorly designed question for my part. If you didn't know what to do with 5, that is okay. It would be unreasonable for me to expect you to look at 5 and go, oh, I know what he means, because I read it and I'm not sure that anybody would have known what I meant. So what I had intended was you to make this assumption, that it was kind of continuing to go up and down, up and down, up and down forever. Now that's probably not fair for me to have assumed that you would have gone, oh, that's what he means. But this is what I meant. So let's answer this question. We'll do the whole question, all the parts of it, now that we've kind of established what I really meant. Okay? Okay, so I'm going to erase that part since we've kind of drawn in what it was that I meant. So the domain. It's continuing to go forever to the right. Yes, and forever to the left. And it's connected in between. So it is negative infinity to positive infinity. The range will not be so. So if I find the lowest point on my graph, well, there's a bunch of lowest points. But they all look like they line up at -1. And the highest points, well, there's a bunch of those, but they all look like they line up at +1. You guys agree with that? So my range would just be -1 to +1. I'm going to use a bracket here because I have a point here at, like, I don't know, -9.7 or -1.9 that has the y coordinate -1. That would be incorrect because you're describing like a discrete set. So this is saying the only y coordinates used are these 3. But like this has a y coordinate that isn't one of those 3. Right? So
Is that like more like you get to the range between the
yes.
Okay.
This is just 3 specific
That's like
values.
exact.
Mm-hmm.
That makes
So if you had specific points that you're talking about, that would be a reasonable way to describe your.
So if you would have put points on this, then we would do it like that. But
If it was just points, if
okay.
nothing was connected, if it was just like
So this is
a bunch of dots,
Okay.
then doing something like this would be perfectly appropriate.
Okay.
Or if it was like a straight horizontal line where like there's only one y coordinate that gets used, something like this would be appropriate. Where there's not a range of y values, but there's just like a couple. Does that feel okay? Maddie, are you good? I'm sorry, I called you Maddie. It's Mackenzie. Are you okay?
Yeah.
Did I answer your question? No. I meant just about the okay. Ava.
Yeah. So for increasing decreasing constant, do you get the x coordinates or the y coordinates?
Okay, good question. For positive, negative, 0, increasing, decreasing constant, we're always describing with x's.
Always x. Okay.
Yep. So that's what we're going to do next. And we are going to get to the end behavior, I promise. I just felt like we should just do the whole thing because if we just did the end behavior part, somebody would ask about the rest of it later. Before I do that, Maya. Yes. So the smaller number always needs to come first in your interval, because what this is equivalent to saying is this inequality, if we reversed it, that inequality doesn't make any sense because there are no numbers that are greater than 1 and less than -1. So that would be not correct if you reverse them. But hopefully it's easy to remember that just like when you write your interval, always the smallest number comes first. Okay, should we do the positive negative part? So if I look at this, I see I have a positive part here, a positive part here, a positive part here, but I'm going to keep getting positive parts in both directions, right? There's infinitely many of them. So how do we describe this? Okay, that's one way of trying to do it, although the issue is that when you get the 6.2 positive infinity, that's not quite correct because it's doing this. So there still are negative parts after 6.2. So it's not positive the whole way, but we are going to do something similar to what you're describing. So since there are infinitely many of these positive intervals, I'm going to use a squiggly bracket to describe these infinitely many. So what I'm going to do is I'm going to say, okay, I'm going to use this, this particular positive interval. So that starts at 0 and ends at, I'm going to call that 3.1 is what I'm going to estimate it as. So 0 to 3.1 is one of my positive intervals, right? And then if I go, the next positive interval starts at, say, 6.2 and would end at like 9.3. Notice to get that, I'm just taking this and adding, I'm taking, 0 and I'm adding 6.2 to it. And if I take this endpoint and add 6.2, I should be at the end. So the way I'm going to write this then is I'm going to write this as 0 plus 6.2k and 3.1 plus 6.2k, such that just k is some integer value. So what's that saying? Well, when k is 0, we're just talking about that piece. When k is positive 1, we'd be talking about that piece. When k is negative 1, I would talk about this piece. When k is positive or negative 2, it would be this piece. If it was positive 2, it would be like that stuff out there. So that's a way to describe those infinitely many positive intervals where they're all equally spaced apart and they're kind of predictable about when they're occurring. Now, would I expect you to come up with this on your own on a test? No. Goodness, no. No. This was very tricky, right? Like, I didn't use any notation that you're not familiar with, but I used it in a very kind of clever way that's not obvious if you haven't seen that before, right? And would I, the first time you're seeing it on a review, would it be reasonable for me to expect you to do it on the test? No, but it forces us to kind of review some of these ideas of like these different kinds of notations and how to combine stuff together. And it's certainly, if you understand this, the things on the test will be much more straightforward. So I don't think it's, and then plus it gives us opportunities to talk about some of these interesting things. So don't get freaked out if you're like, dude, I would not have come up with that. That's okay. I wouldn't expect you to do that on the test. Okay? So the negative, we're going to do kind of the same idea here. So for the negative, let's do this piece here. So we're going to go from negative 3.1 plus 6.2k to 0 plus 6.2k, such that k is an integer. So the same kind of idea, right? Once we've seen it once, it's a little bit more obvious, like kind of what I'm describing here, hopefully. Yes? Okay. The 0, well, that's going to be, the zeros are just distinct points, right? Everybody agree with that? Okay. So these zeros are just going to be a set of x's such that x is going to be equal to, and I'm just going to pick one of these as my starting. So I'm going to pick that one there at 0. And then I notice that every 3.1 units, I'm running into another 0. So I'll just call this plus 3.1k, where k is a integer. So here's what I would say, Mackenzie. If you did say like ... negative 6.2, negative 3.10, 3.1, 6.2, ... like that, I would probably have marked that right. Because that's really what's going on. Now, what we've written up here is technically a little bit nicer because it's actually describing to you how to find those infinitely many. But if you did this, did what I wrote there below, indicating there are infinitely many, they're going in both directions, the spacing between them is appropriate, I think that that's a perfectly reasonable answer to give, and I would mark you down for describing it that way. If you didn't have the ... dots at the end, I would mark that completely correct, because you're failing to acknowledge there's infinitely many of them. Or if it was only in one end and not the other end, I wouldn't give that full credit either. But if you had the ... to the start and the ... at the end, written like that, I would say that's fine. And if you did what you were describing before with like the positive pieces, like if you had 0, 3.1, union, 6.2 to 9.3, union, and you had ... here, and then you did like that with some ... dots at the end, I would probably mark that correct. Does that feel okay? And these questions like, hey, if I did this, would this be okay? Is exactly the kind of thing that I think is appropriate to do here, right? There's lots of different ways we can represent things. It's about communicating your understanding to me. I think that what Maddie described there before, I think does a nice job of, I'm sorry. I'm going to get it, I need to get it right. You can stop me whenever I do it. Just go, and I'll know that it was just, I said the wrong name. But it, like you had communicated exactly what was going on here, I think effectively. Would it have, like, is it technically the neatest way of doing it or most compact way of doing it? No, but that doesn't matter. There's not points for style, right? It's either like you've done this correctly and communicated it, or you didn't, and there's maybe something wrong with it, but, like, it's not a style thing. So, does that feel okay so far? I know we still have more to do on this, and I've been taking my time getting through it, but there have been a lot of side questions and like a lot of what if questions, and I think that's good, and I'm happy to answer those things. Amy. Okay, so k is like this little variable here. So k is just a variable name. I didn't want to use x or y because I didn't want it confused with the x or y coordinate. But there's nothing special about the letter k. You could have used any letter you wanted. And then this symbol is like that, like curvy E. It's like the set membership symbol. And then this is the integer symbol after that. So what it's saying is that k is a member of the set of integers. So k can't be a decimal, but it could be like -1 or +1 or whatever. So for example, if we're talking about the positive intervals, when k is 0, we're talking about this part. When k is 1, we would add 6.2 to both the endpoints. We'd be talking about that part. When k is 2, we'd be adding 6.2 twice. We'd be talking about the next positive part. And if it was negative, we'd just be going back in the other direction. Does that make sense? You're welcome. Okay. Increasing, decreasing, constant. Sound good? Okay. Let's do the easiest one first. Obviously, there's no flat section, so there's no constant part. To do the increasing, decreasing constant, though, I'm going to use this same notation that I've introduced for the positive, negative, 0, since there's infinitely many of these intervals. So, for example, my first increasing part maybe is this section here. Let's use that one. Okay with that? So I would say that goes from like negative 1.55 to positive 1.55. I picked that because 1.55 is halfway in between 0 and 3.1, which is 0 to 3.1 is there. So that top of that looks like it's halfway in between. If you had estimated that at something different, I wouldn't mark it wrong because I didn't label any points on there for you to use specifically. So I'm just telling you why I chose that as my estimate. So I have negative 1.55 plus 6.2k to positive 1.55 plus 6.k such that k is an integer. Is everybody okay there? Looks very similar, right? The only difference is the starting and ending points have changed, but all the rest of the notation is the same. For decreasing, let's use, say, this decreasing section. So that's starting at 1.55 and ending at 415. So I have 1.55 plus 6.2k and ending at 4.15 plus 6.2k. Such that k is an integer. We okay there? Okay, and now finally, roundabout way, getting to Maddie's original question about the end behaviors here. Sorry it took so long. And I did it again, and you didn't buzzer me. I'm sorry, I don't mean to keep, like... Okay. Well, take it as a compliment. You had a good big sister, right? Okay. So, again, the end behavior is describing what is going on at the arrows at the end of the graph, right? So, if I think about the arrow at the end of the graph, is it always doing the same thing? Is it always pointing up or always pointing down or always pointing to a specific value? Like it's kind of pointing down sometimes, but then it'd be pointing up, but then it'd be pointing down. It's not really settling into some specific direction, right? So what would we say that the end behavior is? Still none. Because it's not going always doing something, right? Or doing one thing.
So like for 6, if the line goes to the right, goes to the right, if that was like an arrow, then you could say
Okay.
oh,
So let's say that we have this graph. Sound good? And this is a reasonable facsimile of 6, right? I mean, I connected the stuff in the middle, but like that doesn't matter. Is that okay, Mackenzie? Okay. So let's just say that this is at like -5 over here. So this end is like -∞, comma, -5, right? It's going to the left, so that's the -∞ part, but it seems flat at y equals -5. So the way I'd write this end behavior is I'd say, okay, as x approaches -∞, y approaches -5. Is that okay? This end is at is the point +∞, comma, +∞. It's going to the right, so that's the +∞, and it's pointing up, so that's the y coordinate, +∞. So here I would say x approaches +∞ as y approaches +. That's it. Is that okay?
yeah.
Not a big deal, right? And this was a good, you started doing like a what if, and I just, rather than drawing on 6, I just kind of drew up something to, I think, answer your what if question that you had going. You feel satisfied? Cool. So takeaway here. Question like number 5, would this be appropriate for a test? No. I think a question like 6 would be reasonable. I think 7 would be too long in terms of writing out your answer to me to put on the test, because it gets quite lengthy because there's so many little intervals to deal with. Amy? Sure. Okay. The domain is -7 to +7 with brackets. The one place we have to be careful is this graph isn't connected. Notice that there's this part right here is not connected, but it's okay because the x coordinates are overlapping. Everybody see that? If the x coordinates weren't overlapping, there's like a gap in the x, then you would need 2 separate intervals to describe it. Okay? Amy, you feel okay there? Okay. Let's do the range. So the range, we have this part, which has the y value -2. That part all has the y value -2, correct? But then we have a bunch of missing y values, and we go from 0 to 4. Agreed? So I'm going to do this using, I'm going to have to use a union here. So I have the squiggly brackets because I have the one y value -2 that's used on the flat section. And then I have bracket 0 to 4 for all the y values that are used on the other section. Mackenzie.
If I wrote the note as the bracket -7, -6 bracket union parentheses -6 +7, that would also
That'd be okay. That is equivalent. Well, because I have, for example, this is right here. So I have a point that uses the y-coordinate 0. Now, if we're talking about intervals of positive and negative, that's a horse of a different color there. But for this, for a range, I'm not so concerned about where the points are. Just what I'm concerned about what the coordinates are. You know what I mean? Does that feel okay with everybody? So this was a little bit sneaky, having to add in that extra -2 there, but I think we had done an example where something like that had happened, so it shouldn't have been too unfamiliar. So positive. How many positive parts do you see? You really need 3. So we have a positive part here that goes from -6 to -4. And then it becomes 0 at -4. And then we have a positive part here from -4 to +4. And then it becomes 0 at +4. And then I have one more negative part here that goes from 4 to 7. I can't write this just as -6 to +7 because we have those spots in between where we're 0. Right? Oh, sorry. This is what you're going to ask, right, Ava?
Yeah.
Yes. Yeah. That should definitely be a bracket 7 at the end.
So why does the zeros matter again? Like,
So the definition of positive is the part of the graph that's above the x-axis. At those specific points, the graph is on the x-axis, not above it. So those should not be included with the positive parts. Is that?
yeah.
Okay. Ava.
So why are they all not brackets? They're all exact points on the graph. These are all like points.
So that would be true if it were talking about domain and range, which are just talking about the x and y coordinates that are used. Positive means the parts of the graph that are above the x-axis. We are not above the x-axis at these 3 spots. So those cannot be included with the positive parts. Even though there is a point there, the point is not above the x-axis.
So what about the 4 at the end of the point, -4, 4? Would that be bracket 2?
This,
4.
uh,
Right in the middle.
oh, here? It's in this stuff, right? That's 0, 4. So the 0 is included. It's in between -4 and +4. So because I didn't write it as a separate interval, I just wrote this as one big thing.
Right.
That's that interval. So the 0's inside of it already. It is included. If you wrote it as -4, 0 bracket, union 0 bracket 0, +4 parenthesis, that would be fine. But that's more writing than you need to do.
Okay. Thank you.
Edmund.
Can you explain the range?
Yeah. So this stuff down here all has y-coordinate -2. That's that single -2 there.
It's isolated.
Yeah, there's nothing connecting it to the other, so there's no y-coordinates used anywhere in here, right? Like this part of the y-axis, if I trace over, there's no point. Does that feel okay? These are good questions, guys. Okay, Sergio.
Say you shifted like that entirely. Would that like change everything?
Yeah, so if you translated up 1, all of these things would be brackets. And you could actually just write it as one single interval.
Yeah, but would that be so that would be bracket?
Yeah, if you did this, you could just write it as bracket -6 to 7 bracket. You wouldn't need to separate it out because all of the points are above the x-axis now. You could do what we have here and just make everything a bracket. That would be fine also. But this is a bit quicker. Jack.
I just have a general question about increasing and decreasing constants.
Yes.
Is it always parentheses for those, or can you do brackets?
Those will always be parentheses. You're welcome. Okay. Negative part. Well, there's just one negative section. It's right here. And it goes from -7 to -6. And we'll use a bracket on that because all of that is below the x-axis. Everybody cool there? And then our zeros are just individual points, right? They're just 3 individual points. So we can do -6, -4, and +4. And just list those individually because it's not a range of values, it's just 3 specific values that are where the graph is at the x-axis. Is that okay? Okay. Increasing. How many increasing sections do you guys see? I see 3 also. I see this one here, and this one here. Agreed? Okay. Remember, as Jack just asked, all of the increasing, decreasing constants are always with parentheses. So you don't have to think too hard about these ones. So we'll go -6 to -5, union. -4 to 0, union. And then 4 to 7, union. We have 2 decreasing sections, here and here. So that's -5 to -4, union, and then 0 to 4. And then we have 1 constant here from -7 to -6. Do we feel okay there? I think the increasing, decreasing constants, it may be even a little easier because you don't have to worry about the bracket parts, which makes life a little bit simpler, right? Edmund?
So for the positive part, why can we go from straight from -4 to 4? If we're doing that, why can't we connect that row side as well?
Sure. So if I look, positive is above the x-axis. All of that is above the x-axis, right? The whole stretch. So that can all go together into one interval.
But then why can't you connect the little side?
Right, but it isn't over the x-axis at that specific point.
Oh.
So it stops being above right there, and then it stops being above right there. So we need 3 separate intervals to do that. Does that feel okay?
Yeah.
And again, that's tricky, right? Like, it's like, why can I just, you did it, sometimes it's all in one, sometimes you're breaking it up, and you got to keep reminding yourself about those definitions, about what it really means to be positive. Amy, the constant is this piece right here, the flat part. Yes. Yep. We're always for positive, negative, 0, increasing, decreasing constant. The intervals are always x to x. Yes. Good questions. Again, making sure we understand like how to use the notation is really important, right? The format of the notation, that matters a lot. Sergio.
I have a question on the next one. So,
Okay.
because they're not sharing the same x-axis, how would you?
So you're going to need, what is there? There's 8 separate loops, and there's a gap in the x between each of the separate loops. You need 8 intervals for the domain. This is why I said it was too much writing to put on the test. Now, if I've had 3 of these on there, I think that's reasonable. But 8 of them, it's just like, this is a lot of stinking intervals to write. So, for example, the domain would be -7 to -6, union, -5 to -4, union, all the way down to positive 7 to positive 8. And I did a dot, skip a few in there because I didn't want to write all 8 of them down because you got the idea at some point, right?
Yeah.
And you'll have to do the same thing. You'll use a bunch of different intervals for the positive, negative, 0, increasing, decreasing, constant. Well, the constant part there is none, but because it's not flat anywhere, right? Doritos.
Would those be brackets?
Oh, very good question. Yes, those should be brackets. Thank you. I got excited.
Except for one of them.
No, these all, for the domain, these are all going to be brackets. There is a point there. It's maybe hard to see. Here, when I'm doing the negative part, I would use a parenthesis there and not a bracket. Yes, but for just the domain or range or whatever, those will be, I'd be using brackets there. Is that good, Mackenzie?
Wait, why would you use those brackets?
So she asked about those 2 points there that are on the x-axis, about whether they need a parenthesis or bracket. And I said, if you're doing the negative stuff, you need a parenthesis at those points because those points are not below the x-axis, they're on it. Similarly, you would use a parenthesis at those for that part too, on those endpoints, because again, they're on the x-axis, not below it. But if you're just talking about the domain doesn't care about the location, it just cares what the coordinates are. Is that okay? Alyssa.
Can you just give me the answers for number 4 on the review?
For number 4? That is a function. It would pass a vertical line test. Its domain is all real numbers, so negative infinity to positive infinity, and its range is bracket 1 to, negative infinity to 1 with a bracket. Like that. I wrote it down. So if you write it this way, any x you pick, you're going to get a unique, you're going to get just one y value for that x, right? Since there's no, when I rearrange it, there's no plus or minus floating around anywhere, is usually a good giveaway. Amy? Number 12? Sure. Okay. You're talking about this one, though. When you said the last one, I assume you're looking at this. Okay. So there's 2 things that I'm going to use here. I'm going to use this general form for a transformation to identify the values for A, B, H, and K. And then I'm going to use this to write a transformation map so I can transform the coordinates that are on the graph to the new coordinates that I'm going to use to make my new graph. Okay? So if I take, for example, number 10, and I try to write it in this transformational form, I don't see any number out front of the f. So the number that's out front of the f when there's no number there, because it's multiplication, would be a 1. Similarly, there's no number out front of the x here inside of my parenthesis. So that would just be a 1. I'll write it as 1 over 1. Next, I have a minus sign here, but a plus sign here. How do I write an addition problem as a subtraction problem? I do minus a negative, right? So this will be minus negative 2. And then I have the plus 3 at the end. So I see that A is 1, B is 1, H is -2, and K is 3. So my transformation map then will be x minus 2y plus 3. I didn't bother to write the 1 in for A and K, or A and B, because 1 times anything is just itself. Okay there? Okay. Those 3 points on my picture. And I'm going to do that arithmetic there. So I'm just going to plug in the value for x and y into the map that I wrote. So that's one of my new points. That's my next new point. And that's my last new point. So now I'll just go back to my graph and plot those. So that's 6, -2, 0, 4, and then 2, 2. And there is my new image. To do this question, no, but I think the previous question asked you to describe the transformation in words, the other number 12. And there you would use it. And sorry, I did 10 and not 12. But it's like 6 and 1/2 dozen the other, right? If you can do 10, you can do 12. So, does that feel okay though, Amy? So it's not probably as bad as maybe you thought, right? You just, the key is knowing how to use those two tools. And if you have those, it's just kind of a plugging in things, right? You're pulling the values for A, B, and H and K off of the equation, and then plugging those numbers into this map, and then just grinding through the points that you're given. And on something like this on the test, I wouldn't give you more than like 3 or 4 points that you'd have to transform, just because of time, right? Like having 20 points doesn't make it more challenging. It just makes it more tedious and more time consuming. I don't need it to take a million years, right? Like 3 or 4 points is enough to get an idea of whether you know what you're doing or not. Let's pause here for a minute because we still should take these last 5 minutes and kind of talk about test format. Okay with that? Okay. In general, the test will be kind of a similar style and format to the review. Okay? It will be shorter than the review, and it'll be easier than the review. So I would say that like the easiest questions on the review are probably at the level of a hard question on the test. So like, if we go back and talk about these 5, 6, and 7 that we spent a ton of time with, I think 6 is an appropriate hard level question on the test. I think 5 and 7 are far too difficult of things I would put on the test. Either they're too time consuming or they're too tricky or whatever. Things like 2, 3, 4, 5, or 1, 2, and 1, 2, 3, 4. I think 1 is too difficult to put onto a test. I think 2 is reasonable. I think 3 is definitely reasonable. I think 4, I would probably give you an easier equation than that. That's something that's a little bit more familiar that you'd know what the graph is right away if I were to give you an equation. Probably some of us didn't look at that and immediately know that it's going to look like a parabola, which makes this problem really easy if you identify that immediately, but most of us probably wouldn't have identified that immediately. Also on the review, we didn't talk about this, but you should be able to describe the transformations with words. So that's that part that Amy was asking about, do I really need to memorize this list of things? You do, because I am going to ask you to describe them in words. And then this part here where I will definitely give you a question where I ask you to find the maxes and mins with your calculator. So again, we have a video from the last lesson where we did that. if you don't remember. I don't have time to do it right now because we're out of here in like 3 minutes. Wasn't watching the clock very well and things got away from me, but that's okay. Right? We did a lot of good work here today. Right? You guys, I think, asked a lot of questions. Hopefully you feel a lot better about things. I tried to be really specific and helpful and really kind of go through things in great amount of detail and answer a lot of what if questions and answer the same kind of questions a bunch of different times, a bunch of different ways, which is perfectly fine. But that's kind of what I would expect for the test. It will be shorter and easier than what you've seen here. The questions that are kind of all the same question over and over again, like if you can do one of them, you can do any of them. Like what we just saw with this 10, 11, 12, expect like one of those. Or describe the transformation in words. If you can do one of those, you can do any number of them. You could expect like one of those. Or, find the maxes and mins on your calculator. Like if you can do that once, you can do that 20 times. Just expect like one problem like that. Sergio?
What do you mean by
So like, we'd say that for this one, we identify that A is 2, B is 1, H is 3, K is -2. So we'd say, like vertical stretch, this does nothing. This like translates to the right 3 is like down 2. So like we had a big list of criteria on what each one of them did. I'm talking about just using that criteria to say what's going on. Now I did that like incredibly briefly and quickly. I would expect a little bit more writing than that from you guys, but I just wanted to give you a feel for like what it is that I meant on there, because that sounded like really what you're looking for, not like how do I do the problem, but what does the answer kind of look like? So I did that quickly with words and like a little bit of scribbling, and that's not even really legible scribbling now that I look at it. So I apologize there, but I think that probably gives you the picture of what you're looking for. Edmund?
I don't completely recall this, but I believe you put like a sample graph to describe the behavior. I think I missed something there. You saw that.
Yeah, I'm sure I did. Oh, that's because I'm looking at the wrong thing.
Thank you.
How would you write, like I know I already emailed you this, but for the vertical stretch, like how would you write that for points wise? Like is there an equation, like I know when it's like +3 you do like b something +3 for like going left, but for vertical stretch is it like something certain on a graph at least? So,
Okay, I'm sorry. Can you repeat your question
for
one more time?
vertical stretch, so like
Yes.
let's say it's this is a vertical stretch by 3 halves.
Mhm.
How would you write that on your, how would you make that points wise? So like how would that switch this point
Okay.
3 halves?
So what we're using is this map. So on this one, the map we would write would be 1x plus 2, 3/2y plus 0.
Okay.
So if I took the point, say, -4, -5, that's going to turn into -4 plus 2, 3/2 times -5, and plus 0.
Okay, yeah.
And that turns into like -2 and then -7.5.
Okay. And then all the equations like that are on the, well, you've already wrote that down probably somewhere.
They're definitely in the notes, but
Yep.
they're also on your sheet right here now.
Perfect, yep.
So
Thank you
you've
so
got
much.
it right there where you need it.
Thank you.
You're welcome. You feel better after today?
Yeah, I feel a lot better.
Good. Digital crew, are you guys feeling okay? Did you get what you needed?
Yeah, I was gonna say, I think I'm doing good.
Okay. Natalia?
I have a question.
Sure.
Can you do like one of 10, 11, 12, or 13?
Yes. So like these ones right here?
Yeah, the describing the transformation.
Okay. Sure. So, Natalia, the tool that I'm using to do this, if I go back and I look at the notes from 9.2, just so you know how I'm doing this, is I'm using this list of criteria right here. Okay, so that's how I'm coming up with what everything does. So here, just like we did on the other number 10, I'm going to start by trying to rewrite or use this to find out the values for A, B, H, and K. So here I can see that the A is 2. There's no coefficient on the X, so the B is just 1. The H is 3. And then the K is -2. Are you okay with how I did that?
Yes.
Okay. So now I'm just going to go to this list and I'm going to say, okay, since the A was positive, there's no reflection. And since the magnitude of A is greater than 1, I know there's a vertical stretch by a factor of whatever it was, 2 or something. And now OneNote wants to try to crash on me, so it's going to take a minute to switch back, it looks like. Okay with that? So since A is equal to 2, and that's greater than 0, I can say there's no reflection in the x-axis. And since the magnitude of A is also equal to 2, and that's bigger than 1, I have a vertical stretch by a factor of 2. Since the B is equal to 1, that's greater than 0, so I have no reflection there on the y-axis. And since the magnitude of B is 1, I have no horizontal dilation. Since the H value is 3 and that's bigger than 0, I know I'm going to be going right, just 3 units. And since the K value is -2 and that's less than 0, I know I'm going to be going down, and it's 2 units in that case. So this is what like your answer would look like. It's just describing like what you're doing. And
Okay.
that description is just coming from this list here.
Oh, okay.
Thank
you.
Does that work?
Yes.
Much easier than maybe what you're thinking, yes?
Yeah.
Okay. Very good.
Thank you.
Yeah, you're welcome.
Great, thank you. Bye.
And I sent you guys an email about how the test is going to work. So check
Okay.
that, and if you have questions, send me an email or whatever.
Okay, got it. Thank you. Bye.
Yeah, you're welcome. Bye. Share.